Hello everyone. I will be talking about the subject hydrology and irrigation engineering. So this session will be starting with module 1. So let me start with the introduction to hydrology. So let me first define it. Hydrology is the science of water. It deals with the occurrence, distribution, circulation of water on Earth, Earth's surface, Earth's atmosphere, and below the Earth's surface. It may also be defined as applied science concerned with water on the Earth in all its states, its occurrence, distribution, and circulation through the unending hydrological cycle of precipitation, consequent runoff, stream flow, infiltration, and storage. Eventually, the most important processes such as evaporation and reprecipitation. Hydrology is a highly interdisciplinary science. It draws many principles from other branches of science such as climatology, meteorology, geology, physical geography, forestry, oceanography, hydraulics, ecology, etc. Now, let us know how it is concerned with different forms of water. So, hydrology concerns itself with three forms of water: above the land as atmospheric water or precipitation, on land or surface as stored water or runoff, below the land surface as groundwater or percolation. So, atmospheric water, surface water, and subsurface water or groundwater. So, here hydrology is concerned with the water in all these three forms. Now, let me talk about the importance of water. So, we all know water occurs practically everywhere and in different forms. All the forms of water are very useful to humankind. We know water is vital for all living beings. No life exists without water. Human beings, plants, animals, birds all need water for their survival. It forms the basic necessity to survive. Water exists in different forms. It also gets transformed from one form to another. We know water is a chemical compound which is made up of two hydrogen and one oxygen atom. Water forms the most important natural resource. The weight of the water, the density of the water, the energy of the water all play an important role. The weight of the water is very important in the hydroelectric power plants to generate electricity. This water falls from a great height to run the turbine where it finally generates electrical energy. So the kinetic energy of the water gets converted to mechanical energy by running the turbine, which further produces electrical energy. The density of water helps to float the boats. The energy of water produces steam, which helps to run the locomotives. In this way, all the forms of water play a very, very important role. Thus, water becomes the most important natural resource available on the earth. Water is a basic necessity. Water is a comfort. Water is a luxury. So, because we don't survive, we cannot survive without water, it forms the basic necessity. So, for all form of life to exist, water is necessary. Second, it is a comfort, which means without water, we are going to feel uncomfortable. It creates unhygienic conditions. So, for a comfortable living, we need a good supply of water where it is available in quantity and quality. So, good quality becomes necessary as well as sufficient amount. The quantity also becomes necessary. Next, I said water is a basic necessity, a comfort, and a luxury. For a luxurious living, we need sufficient quantity of water. It helps us to maintain gardening, the cleaning of the parks, for maintenance of mountains, fountains. Then it also uh, has recreational opportunities where we can enjoy playing water games. Hence, I can finally say water is a basic necessity, a comfort, and a luxury too. With increased population, there is increased industrialization, urbanization, agricultural activities, irrigational activities. So all these require water to a large extent. So the demand of water is increasing day by day by leaps and bounds. Thus, it forms a great important resource. Secondly, with the advancement of science and technology, human beings have a desire to control this water resource. So to have a control on this resource, you need to study the various natural laws, the properties of water, the occurrence of water, the distribution of water, the natural phenomena which occur in this hydrology. At the same time, water also has some serious natural calamities. There are floods, there are severe storms which may occur, droughts which may occur. Hence, these natural calamities which occur can lead to destruction. So, to prevent such floods, severe storms, one needs to study the occurrence of water, its huge distributions, its huge flow which occurs in nature, the natural phenomena, the properties, the laws, all of them can be read, studied under this subject of hydrology. Now, moving on to the global water distribution. We know the total water present globally is 1.36 into 10 raised to 8 kilometers square or 1.36 into 10 raised to 14 hectometers. The total area of water is 3.05 million kilometers square. The precipitation or the rainfall, because the amount of precipitation which occurs mainly is in the form of rainfall in our country. So it is around 1990 mm per year. Out of this, the runoff which we get finally is just 46% of that precipitation. Now we know there are huge losses due to evaporation and they make up around 642 mm. Now coming to the water distribution globally, what is happening on our planet Earth? We know Earth is also called a blue planet because 71% of the Earth is surrounded with water. So when this Earth is observed from the space, it appears blue in color. Hence, we call it as a blue planet. Now, in this globally distributed water, The salt water, that is the ocean water, the saline water, makes up 97.2%, and remaining 2.8% is the fresh water. So fresh water is present in lakes, ponds, rivers, streams. Among that fresh water, we have surface water and groundwater. Surface water makes up 2.2% and groundwater 0.6%. Among the surface water, which is 2.2%, again we have a division which is present in the form of ice. It makes up 2.15%. Rivers, streams and lakes just 0.01%, which is available to us. And other forms make up 0.04%. Then the groundwater, which is 0.6%. In that, only 0.25% can be economically extracted. Rest 0.35% is present at a greater depth and which cannot be extracted so easily. Let us see the figure. So you can see this global water distribution. So this 97% is in the oceans. So it is saline water, salty water. The rest 3% exact is 97.2, but a round figure is considered here. So 97% as salt water or saline water or the oceanic water, and remaining 3% is fresh water. So in that, groundwater makes up 30.1%, ice caps and glaciers, which make up a large percentage of 68.7%, and which is not available to us. This surface water is just 0.3%, and lakes make up a major portion, around 87% of that surface water. Rivers just 2%, and the swamps or the wetlands of the marshy areas make up around 11%. Moving on to the next topic, that is scope of hydrology. So let me tell about the scope of hydrology, which is discussed in 4 different points. The first one, maximum probable for flood, water yield from a basin, groundwater potential, maximum intensity of storm and its frequency. Now, we know when we study about hydrology, we are going to estimate these floods because they are the ones, or it's a natural calamity which occurs and leads to huge destruction. So the maximum probable flood that may occur at any given site, its frequency, they are very much required for the safe design of any hydraulic structure, that is a dam, a drain, a culvert dam, a reservoir, a channel, and other flood control systems. So the subject, the study of hydrology, helps us to predict this and also helps us to prevent and have some control measures. Next, the water yield from a basin. What is this? We know we need water for various supplies. It can be for domestic supply, municipal supply. It can be for industrial supply, for irrigation supply. So all the activities of humankind need water. So to know its quantity, its quality, we need to know the source. We need to estimate the yield, the water yield which is present in any basin, its occurrence, its quantity, its quality, its frequency, all are necessary in the design of dam so the water can be stored, supplied for the various domestic purposes, even to generate water power. For river navigation, we need to estimate this, which is done under hydrology. Next, about the groundwater potential. So we know the groundwater is present below the earth strata. The precipitation which gets infiltrated will be stored as groundwater. So this water is going to supply at a great quantity when surface source is not available. Hence, we need to study about its potential, how much quantity is available. So the groundwater development, for which a knowledge of hydrogeology of the area, the formation of the soil, the recharge of the groundwater, what is the rainfall pattern there, what is the climate there, what are the cropping patterns present there, all are required. So this helps us to understand what is its potential. So hydrology can help us in knowing the potential of groundwater. Next, the maximum intensity of storm and its frequency. So we know a storm occurs with a certain intensity. It can be minimum or maximum. To know this, what is its maximum capacity, what is its maximum frequency, they are all required for the drainage projects, for the design of drainage facilities, drainage projects in any area. We should know about its intensity, its frequency. If the sewers which carry the storm water, they have a lesser capacity, then the flooding can occur. So to have a proper design of this drainage facility, one should know what is the maximum intensity of any storm. Hence, the study of hydrology helps us to know about it, and we can design the drainage projects in a proper manner in any area. Now, coming to the importance of hydrology. So the first one is design of hydraulic structures or construction of hydraulic structures. So what are these hydraulic structures? These are the dams, the spillways, the causeways, okay, the bridges, the wells, all these make up our hydraulic structures. So these are in contact or continuous contact with water. For such happenings, we need to know, we need to study about it. So accurate hydrological predictions are necessary so that these hydraulic structures will function properly. So there is a proper functioning. Hence, due to a storm, the flow below a bridge has to be properly predicted. Improper prediction, what will happen? It may cause failure of that particular hydraulical structure. Similarly, even the spillway, in case of a dam, which is meant for disposing what? Excess amount of water. That also has to be properly designed. So in case we do not estimate properly, we do not study properly, then the design will be a failure. Hence, we should study about this flooding, about the estimation. That all will help us in designing proper hydraulic structures and maintaining them. Next, coming to municipal and industrial water supply. So what is this? We know the water source will be present in the near vicinity of any town, any village, any city. And it is that source which is going to be a main supply for various domestic purposes or even industrial purposes. So we need to study about that source because the entire city, the entire town, the entire village is dependent on that city because it is the main source which is going to supply water. So it is that source which supplies us with fresh water. So the fresh water availability in that particular vicinity of any town, city has to be studied properly. Water should be drawn from rivers, streams, groundwater. Proper estimation has to be done of these water resources in that particular place. Then only it will help us to plan properly and implement the water project, the domestic water supply, the industrial water supply properly. Next, coming to irrigation. So irrigation is nothing. It is the irrigational facility which is going to be provided for the growing of crops by construction of dams and reservoirs. So dams are constructed to store the water for multiple uses. So this water can be supplied for irrigation purpose or even for domestic water supply. Then the estimation has to be done. What maximum storage capacity of that particular dam is there? The seepage, the evaporation, what happens there? What are the losses which are incurring in that particular dam site? They all can be properly estimated under this subject of hydrology. We have to understand the hydrological features of that particular river basin, and this makes us properly to understand the irrigation project, the irrigation facilities. We can estimate properly, and the proper functioning, the proper designing of any irrigation project can be successful. The groundwater storage will be increased because of these dams. The recharge happens, so that groundwater also will be available. That also can be studied. What potential it has, that also should be known. Example, the Gangetic Basin, it has a groundwater potential of about 40 times compared to the surface flow. Next, coming to the hydroelectric power generation. What is this? To generate electricity, we need water. So, water plays a very, very important role for continuous generation of electric power. We need continuous supply of water. So, a hydroelectric power plant needs continuous water supply without much variations in the stream flow. If there are variations, definitely it will hinder the functioning of the turbines and eventually the generation of electric power. Hence, proper estimation of river flow, the flood occurrences will help us to construct efficient balancing reservoirs, and these will supply water to the turbines at a constant rate without much variation and thus generate electricity. Next, flood control in rivers. So controlling floods in a river is a complicated task because floods are natural calamities which occur in any area. So controlling it becomes a great responsibility. So it's a complicated task. The flow occurring due to a storm can be predicted if the catchment characteristics are properly known. So all the characteristics of the catchment area should be studied well. So here, a joint work of hydrologist and a meteorologist plays a very, very important role because the flood threatening areas should be studied properly by these two people. So they have to work in conjunction, in joint. They need to make a detailed characteristic study to predict the floods so that the damage due to these floods is reduced. Floodplain zones may be demarked to avoid the various losses. Next, coming to navigation, soil erosion and sediment control. Let me talk about soil erosion and sediment control first, then I'll move on to navigation. So what is the soil erosion? We know the soil erodes, that is, it moves away, it is carried away along with the water. So as the water flows as runoff, due to its velocity, this soil or the topmost soil is removed. So the removal of topmost cover of fertile soil is known as soil erosion. So as the runoff starts moving, it carries along with it this fertile soil in tons. So this excessive erosion in the catchment, it is going to finally feed the runoff with sediments. So the runoff is going to fill up with sediment load and it is going to finally join the reservoirs and the sediment load is going to be increased in the reservoir. So all the sedimentation, the sediment particles get settled in a reservoir. What do we say? Reservoir sedimentation. So what happens? The reservoir loses its capacity at a faster rate because of this soil which gets deposited there as sediment. So tons of fertile soil get removed, will be lost every year because of this flow of surface runoff where soil erosion takes place. At the same time, it increases the sediment load in a reservoir, reduces its capacity, reduces its effective span, and simultaneously, it also affects the crop yield because all the nutrients, the fertile soil is lost. The nutrients which are required for the crop growth are lost. It may result in crop failure or the yield may be limited. In this way, soil erosion is threatening the capacity of the reservoir as well as the crop yield. So we need to take certain measures to control this. What can we do? We can have a fixed crop pattern, cropping procedures, formation of contour bunds. When we construct the contour bunds, they can prevent the flow of the sediment. Afforestation by planting of trees. All these measures can be taken which reduces the sediment load and thus help to reduce the peak floods, discharges which carry the sediment load. There is increased infiltration due to the afforestation activities, which helps us in control of the sediment load. Moving on to navigation, we know big canals. Big canals can help us in an irrigation scheme, which can be used for inland navigation. The depth of the water should always be maintained at a constant level. This can be provided or can be achieved by providing lock gates and a proper draft to be maintained. If the river water contains sediments, they will settle in the channel and the depth decreases, reduces, and thus affects the activity of navigation, or it creates a problem, it causes a problem for navigation. Hence, the catchment characteristic should be considered and the sediment entry should be prevented, what I said in sediment control and soil erosion, by constructing contour bunds, by planting trees. All that will help us to prevent the sediment load, and that will help in the navigation activity in any water canals or in big water canals. Now, coming to pollution control. So how does it help in controlling the pollution? It is an easy way to dispose the sewage which is generated in any city, town, or village into the streams and rivers. When the water body is large enough, that is, it has large quantity and the sewage which is generated is comparatively less to the water available, then we can discharge this sewage generated directly into the water streams, water lakes, water rivers. So here, because the quantity of sewage is less and the water available in the source is in huge quantity, a dilution ratio is achieved. And this helps in self-purification of the streams. So we need not to worry about treatment of that sewage, which can be directly disposed. Thus, it helps us in controlling the pollution. But at the same time, we need to know that the quantity should be available in plenty. In case the source has a limited quantity and your sewage is more, then you cannot directly discharge there and control pollution. That may create a nuisance because the dilution factor is not achieved and self-purification cannot be achieved. Hence, you need to check that the water is in sufficient quantity and the dilution ratio is reached where self-purification can be achieved. So we can have a control on pollution in this manner when that dilution factor is achieved. Next, moving on to hydrological cycle. So you all have studied about this hydrological cycle. It's a simple water cycle where the various processes such as, let us see this, evaporation, condensation, precipitation, interception, infiltration, percolation, evapotranspiration, and surface runoff are involved. Let us go back to the figure. So this is a simple water cycle or hydrological cycle figure where you have the Earth's strata, there are mountains, there are vegetation cover, there are water bodies, there is subsurface strata, there are clouds, the sun, which you can see in the figure. So we know water is present on the Earth's surface in all the water bodies. It can be in lake, river, water ponds, streams, and it is the oceans which make up a major portion of water. So huge amount or large quantity of water vapor is generated from this ocean surface. So oceans are the ones which contribute a large quantity of water vapor into the atmosphere. So let me start with the process of evaporation. So the various water bodies which are present on the Earth's surface in presence of solar radiation, sun's heat energy, get evaporated as water vapor. So in this process of evaporation, the water from liquid state changes to vapor state. And it gets converted to water vapor or to gaseous form. This water vapor starts rising up in the atmosphere. As it starts rising up, the quantity increases to such an extent that the space can no more hold it. At such a time, the water vapor condenses to form clouds. So for the process of condensation to happen, sufficient amount of moisture should be present in the atmosphere. At the same time, this water vapor condense over the nuclei, that is, they are the salt particles which are products of combustion to form the clouds by the process of condensation. So cloud formation happens by condensation. So the tiny water droplets are present in this cloud. Due to the speed of the wind, turbulence of the wind, the tiny water particles join together, form bigger water droplets, which the cloud cannot hold, and thus it precipitates back to the Earth's surface. So in this way, evaporation, condensation, and precipitation occur. So these three are the main phases of water cycle. Now, the precipitation which occurs and travels downwards towards the Earth is interrupted by the vegetation which is present on the Earth's surface, or the natural barriers, or the structures, all intercept this precipitation. And that process is known as interception. Some of the precipitation, when it is traveling down in the Earth's atmosphere itself, gets evaporated as water vapor. Remaining portion reaches the Earth's surface after interception. Some portion is utilized in moistening the Earth's soil strata. So it wets the soil strata or soil surface or the Earth's surface. Once enough moisture is present in that soil strata, the excess amount of water, rainwater, the precipitated water, starts penetrating inside the Earth's surface through the pores and voids of the soil surface. That process is known as infiltration. This water infiltrates further into the deep rocky strata, which forms the process percolation. So evaporation, condensation, precipitation, interception, infiltration, and percolation have occurred. So after the percolation process, the water which will have infiltrated deep down goes and joins the groundwater flow or groundwater table. This flow again may have a path which may reach any water body on the surface. Sometimes if there is increased pressure, this water may also come out as springs. Now, after the precipitation has satisfied interception, infiltration, percolation, transpiration is the next process. So this water which will have infiltrated will be present in the upper surface of the ground and below the ground surface also. So the water which is present is extracted by the roots of the vegetation cover of the plants, and it is transported through the stem to the leaves for the process of photosynthesis. As we all know, the process of photosynthesis needs water, minerals, solar radiation, chlorophyll, the green substance. In presence of all this, the plant prepares food. After sufficient amount of water which is supplied from the leaves to the leaves is used by the leaves for the process of photosynthesis, there is some amount of excess of water. That excess water escapes principally through the leaves of that particular plant, what we call transpiration. So that escape of water or transpiring of water is transpiration. But in hydrology, we use the process evaporation and transportation together. So it forms the word evapotranspiration. Because when transpiration is happening from the leaf surface, at the same time, the plant where it stands on the earth will be losing water in the form of evaporation. So the water from the earth surface or from the ground surface where that plant stands loses water in the form of water vapor. So evaporation will be happening there. Simultaneously, transpiration will be happening at the leaf surface. So evaporation and transpiration are always taken together or termed together as evapotranspiration, and this process as evapotranspiration is studied in hydrology. Now, after interception is completed, infiltration is completed, transpiration, evapotranspiration is completed, the excess amount of water is going to flow on the surface, which is known as surface runoff, and it is that water which is going to join the various water bodies which are present on the earth's surface. And this surface runoff which joins the water body is the water which is available for future evaporation. Thus, this water cycle is a continuous cycle. It is a complicated task because we don't know whether evaporation started first or precipitation started first. If we want evaporation to take place, then we need water. For that purpose, transpiration, evaporation, condensation, and finally, the precipitation will occur. So nobody knows whether evaporation is first, whether precipitation is first. So we always define water cycle as a continuous cycle which has neither a beginning nor an end nor a pause. So we know water exists on the earth in gaseous form, water vapor, liquid and solid forms. It is circulated among the different components of the Earth, mainly by solar energy and planetary forces. Sunlight evaporates the seawater or any water in any water body. They get evaporated and they are in evaporated form, which is kept in circulation by gravitational forces of Earth and by the wind action. The different paths through which the water in nature circulates and is transformed is called the hydrological cycle. The hydrological cycle is defined as the circulation of water from the sea to the land through the atmosphere back to the sea, which is often delayed through the process like precipitation, interception, runoff, infiltration, percolations, groundwater storage, surface storage, evaporation, and transpiration of the water, which also returns to the atmosphere without reaching the sea. Thus, these three main phases are very, very important: evaporation and evapotranspiration, precipitation, and finally runoff. So we know evaporation takes place from various surface waters, ponds, lakes, reservoirs, and ocean surfaces. Transpiration through the vegetation cover, that is the plants, through the leaves. The vapors rise to the sky, they condense to form clouds, the clouds precipitate back. So the clouds melt and we get the precipitation in the form of rain, snow, sleet, hail, frost, dew, drizzle, okay, any form of rain. Any form of precipitation. A part of this precipitation flows over the land. Finally, after satisfying infiltration, percolation, evapotranspiration, also after satisfying the soil moisture on the earth's surface, the excess amount flows as surface runoff. This surface runoff joins the stream and thus water can be stored in the reservoirs. A portion of the surface runoff and the groundwater flows back to the ocean. Again, evaporation starts from surface of lakes, reservoirs, and ocean, and thus this water cycle goes on repeating. The hydrological cycle is represented in many different ways. As you all can see, the next figure, it is prepared by Robert Horton. So it is known as Horton's qualitative representation, or we also say Horton's engineering representation of hydrological cycle. So you all can see here clearly the various processes which start with evaporation, evaporation from ocean, evaporation from all other water storage channel storages, surface detention. Then it gets converted to atmospheric vapor that is stored there. It forms clouds. Those clouds get precipitated as rain, hail, sleet, snow, dew, frost. Then that is intercepted by interceptance storage. Okay. Then the further process is done by infiltration, where it gets penetrated into the earth's surface. This goes and adds up to the groundwater table. Then the excess amount flows as surface runoff, again which joins the ocean storage, which again starts evaporating. So this is a continuous cycle. It is a complicated cycle. It is a complex cycle. You can further conclude. So this is all about hydrological cycle. So for your syllabus, you have this Horton's representation. So you have to compulsorily draw this figure and explain about hydrological cycle. Moving on to the last water budget equation for a catchment. The area of land draining into a stream at any given location is known as catchment area or drainage area or drainage basin or watershed. So you can just see a figure here. So this is known as watershed area of any catchment. This are the various tributaries. They are going to join this river. And finally, this station M or the tributary of river A. For a given catchment area in any interval of time, the continuity equation for water balance is given as change in mass storage is mass inflow minus mass outflow. So what is coming in will be leaving at some point. So we have an inflow, there is outflow. So this inflow minus outflow will give us how much water is stored there. So that is change in mass storage. The water budget equation for a catchment considering all process for a time interval delta t is written as delta S is equal to P minus R minus G minus E minus T. What is P? The precipitation. So mainly it is in the form of rainfall. Let us say that rainfall R is the precipitation. Okay, R is runoff, surface runoff, which flows on the surface. G, it is the net ground flow, which gets infiltrated outside the catchment area. Okay, E, evaporation. T, transpiration. So here one most important thing to note is, let me repeat this formula. Water budget equation, delta S is P minus R minus G minus E minus T, where P is precipitation, so the amount of rainfall occurring in any catchment area. R is what flows as surface runoff. G is the groundwater flowing outside the catchment. E is evapotranspiration. T is transpiration, so we take ET together, or evaporation and transpiration. Now, we haven't written about infiltration. We know infiltration is a loss to this precipitation, but yet it is a gain to the groundwater storage. Hence, infiltration is not subtracted in this water budget equation, and you have to make a note of that point and you should remember. So let me conclude this session. Thank you.